Hello, Mr. Wendell here. Today we're going to be doing Lab 9.1. It's looking at pulleys and mechanical advantage. We are going to be calculating mechanical advantage two different ways. One way using distances and another way using forces. The setup for this lab is you are going to use the block and tackle system. There will be 4 weights at the bottom of the block and tackle. It's going to be connected to the second hole down from the top. You're going to be using a 10 Newton spring scale, gold small rope. The 2 red strings are just there to hold the block and tackle together, and they're not going to be used for lifting. First thing we're going to do is we're going to take our force scale and we are going to measure the weight, Newton force, of the bottom block. The block itself weighs 10 newtons, and that is going to be your output force. Your input force is always going to be the amount of force needed to lift the block. So for this first data, we have 1 support strand. The strand that is connected to the spring scale is not considered a support strand. The support strands are the ones that are going from pulley system to pulley system. So we are going to lift the block up 10 centimeters, and the amount of force needed to lift the block up with a single strand is 10 newtons. We're also going to measure the distance that you had to pull the string. That distance, 10 centimeters. The distances that we're going to measure are from top of this piece of tape to top of that piece of tape. That has been measured out as 10 centimeters. And when the block itself moves up to this position, it has moved 10 centimeters. On the other side of the block and tackle system, we have a piece of tape, and that piece of tape was where the string initially is level with the bottom of the top in block and tackle. When I move the block up 10 centimeters, I will then measure from the wood piece to that piece of tape, and that is approximately 10 centimeters. In order to get 2 support strands, we're going to unhook the hook, run through one of the pulleys, come to the top of the block and tackle, and clip it back in. Now we have 2 support strands. We'll also need to loop our section we're going to put our spring scale on, and that's going to hang down. For the second set of support strands, where we have 2, 1, 2 here, again, this is not a support strand, that's what you're pulling the spring scale with. We're going to lift the block, and the force needed to lift the block is 5 newtons. You're going to pull the block up so the top of the block matches the piece of tape, and this is 20 centimeters. For 3 support strands, we come up over the top of our pulley system, down to the block, again make our loop. We're going to use our spring scale to now get the data for 3 support strands. You have to make sure that the support strands are on the pulleys and nothing is in between or crisscrossed. Our next step now is going to be lifting with 3 support strands. And the force needed is 3.25 newtons. We're now going to get the data for the length of the string needed to be pulled. So it is increasing its height by 10 centimeters to the top of the tape. We're going to measure the distance, and I've got 31 centimeters. We will continue to get the force needed to lift the block and tackle, and we will also be measuring the lengths of the strings for the rest of the data from 4 support strands up to 6 support strands. Please take a look at the data table in this lab to get your data in order to do the analysis. This is the data collected with 4, 5, and 6 support strands. In order to calculate the mechanical advantage using forces, you are going to take the output force divided by the input force. In order to get mechanical advantage using distances, you will take your effort or input distance and divide that by the resistance or output distance. Please use these numbers to calculate mechanical advantage.